Hello, my name is Rhian White and I'm a consultant clinical scientist at the All Wales Medical Genomic Service based in Cardiff in Wales. I'm here today to talk to you about a service that we launched in the middle of last year to deliver cancer genomic profiling to patients in Wales. The service is called the Cymru Service for Genomic Oncology Diagnoses, or CYSGODI. So just to give a little bit of context to genomic services and the developments that are going on in Wales. So we're a single laboratory, so there's only one laboratory, one genomics laboratory in Wales, and we serve the whole population of Wales, so that's around 3.5 million people. We provide a range of diagnostic services to the population of Wales, both for rare diseases, for cancer, and for pharmacogenomics as well. We also work really closely with some partner organisations in Wales, for example, the Pathogen Genomics Unit, who deliver the sequencing. And we worked together to use the NovaSeq 6000, which we had delivered back in 2019. We also work really closely with Wales Gene Park as well. So in terms of diagnostic services in Wales, we've launched over the last few years several key high-level services, including NIPT for the prenatal population, a DPYD test, the WINGS service, which my colleague is going to speak about next, and the precision medicine services, which is what I'm going to concentrate on today. So in June 2020, we launched the NTRK gene fusion testing. So this was a test that was commissioned for all patients in Wales. And we worked really closely with oncologists and pathologists to deliver this service and also to produce NTRK gene fusion clinical guidance documents for oncologists and pathologists in Wales. So the majority of our solid tumour and indeed all of our cancer genomic services are delivered by next generation sequencing. We have got several other testing platforms, which I will talk about in a little bit, but we are moving quite rapidly to the majority of our tests being delivered by next generation sequencing. And for solid tumours services, there's some really important reasons why we're developing next generation sequencing. So I'm sure everybody who's listening to this talk knows that for solid tumour diagnosis, you can have a really limited amount of tissue that you've got to work with. We really have to work to a rapid turnaround time to be able to deliver timely results to patients. We work to the UK national guidelines of 14 calendar days. And because of the nature of the testing and the fact that more and more tests are coming online all the time, we have to be able to deliver multiple assays in one test. And the reason for that is that in a patient population who've all got the same tumour, they may have lots of different mutations. So the testing that we set up has to be able to test for all of those different mutations. And a really good example of that is lung cancer. And you can see on the left-hand side of this slide, the range of mutations that you get in different genes associated with lung cancer and the different types of therapies associated with those variants that we find. There's also the situation where you can have a population of patients who've all got different tumours, but all have the same mutation. So we really need to be set up to be able to test for these agnostic biomarkers. So these are the current solid tumour services that we're running at the All Wales Genomics Laboratory, and you can see from this slide that we've got multiple tumour types that we can test for, a wide range of different genes and different variants, and as I have already mentioned, several different platforms that we use. So the majority of our tests are carried out by next generation sequencing, but we do complement that using that testing by using fluorescence in situ hybridization. And I think a really important service that I would like to mention is our circulating tumour DNA service. And that is currently carried out using droplet digital PCR, but we are looking to move that onto next generation sequencing platforms in the not too distant future. I also wanted just to highlight something that I mentioned previously around the amount of tissue that we get. So on the bottom right hand side of this slide, you can see an example of a sample that we might get within the laboratory. We receive the tumour sample, and we receive a H&E slide as well with the area of tumour circled, and we might macro dissect out that area and extract the DNA or the RNA from that. So we're not dealing with very big samples at all. So prior to July of 2021, this is what our Cancer Next Generation Sequencing services looked like at the All Wales Medical Genomics Laboratory. So as I said, we provide diagnostic services to cancer patients across Wales. So we run next generation sequencing services for solid tumours, for the haematological malignancies, and also for germline inherited cancers. And we were running several different next generation sequencing panels. So we were running a Roche in-house pan-cancer next generation sequencing panel, the GeneRead CRM panel, and the Illumina TSO 170 for our CRUK program. For the haematological malignancies, we were running the TrueSight myeloid panel. And for our germline cancers, we are running the TrueSight Cancer and the GeneRead BRCA panel. So running all of these different panels was really challenging, both for our technical services, our bioinformatics staff, and also for our clinical staff, because it meant that they had to be trained to be able to analyse lots of different panels. So this was really set the scene for the driver for change for us in Wales, and as part of our continuous service improvement programme, we wanted to look at the next generation sequencing panels that we were running, and try to standardise them, but also make sure that we'd future-proof the service and to make sure that we could scale up the service. So in terms of future-proofing, we wanted to make sure that we could really rapidly add on additional gene targets, new tumour sites, and we wanted to make sure as well that we were making effective use of all of the resources and the investment that we've got from Welsh Government. And examples of that are the NovaSeq and the Hamilton robots. We wanted to standardise our workflows, as I've already explained in the previous slide. So we wanted to reduce the number of next generation sequencing workflows we were running in the cancer section. And that would enable us to stratify validation and the verification, which takes up a huge amount of laboratory resource, and also to reduce the training workload. We also hope that this would stratify the analysis for clinical scientists and genetic technologists, and also ensure that we've got flexibility for the workforce. And we also wanted to be able to scale up the service, to be able to automate it and reduce batch size limitations, and all of this ultimately with a view to improving the service and the turnaround time for patients. So in October 2020, we went out to tender, and this is the specification that we went out for. So we wanted a comprehensive somatic panel capable of processing DNA and RNA in parallel, able to sequence up to 96 samples. It needed to be in line with the test directory, which I'll talk about in a few slides' time. We wanted to be able to prepare libraries within 3 days, and it had to be compatible with Illumina sequencing, and we wanted to be able to detect all variants in that same panel. So we evaluated 2 bidders, and we awarded to Illumina for the TrueSight Oncology 500 high throughput panel in January 2021. So this is what our cancer workflows looked like pre-July 2021, and what we really wanted to be able to do was transfer as many of these over to TrueSight 500 as we possibly could. So this is the next generation sequencing workflow. So we receive the samples, we carry out the library prep, we sequence them on the NovaSeq 6000, and then the data is transferred to our bioinformatic team. And we've got a really solid bioinformatic workforce in Wales who are really able to react to the needs of the patients and to the different services that we're running. So this meant that we were able to run up to 96 samples from different tumour types, and we were able to detect variants in up to 500 genes. So in terms of our bioinformatic analysis, we're obviously not reporting all 500 genes from all tumours at the moment. We've got a subset of virtual gene panels, and we work really closely with oncologists and pathologists in Wales to develop these gene panels to ensure that we meet the needs of the patients. So this is just a quick summary of the gene panels that we've got currently running, but we're always updating these. So in terms of validation, we're going through a series of phases. So we completed phase 1 in July 2021, where we moved all of our current solid tumour services, both for DNA and RNA, onto TSO 500. Phase 2 we're working on at the moment, and that's the addition of a couple of extra tumour sites, including the angioimmunoblastic T-cell lymphomas. Working in parallel with that, we're looking to automate the workflow so that we can scale up the service. And then in phase 3, which will be starting in June 2022, we'll be combining our hematological panels onto TrueSight 500 as well. And then phase 4 is a continuous cycle of continuous improvement to ensure that we're providing the best service we can for patients in Wales. So in terms of the different services that we provide, we work with and we work to a number of different documents. So I think crucial to us in Wales is really close collaboration with our local service users. We are commissioned to the NHS test directory, so we have to make sure our services are aligned with that. And we also have to ensure that we're really able to rapidly react to new NICE guidelines. So this is a list of solid tumour services that we're going to be adding over the next year. And as I've already mentioned, one of the lymphoma services will be going live first of all, along with endometrial cancer. So this slide just really sums up how quickly we have to, how rapidly we have to react to new changes and new drugs that are coming online. And this service, the CYSGODI service, meant that when these guidelines came out and these new drug therapies came out for patients in Wales, we were already able to report these new variants that were being found. And another really important thing for us is our ability to work with local clinicians to facilitate patient enrolment in clinical trials. And that's something that we've always been really strong in Wales, and TSO 500 and the CYSGODI service is really going to help us to continue strength within the clinical trials arena. So I'd just like to thank the validation team. So this was a real team effort from staff within the All Wales Medical Genomics Service. And just wanted to mention some areas of improvement that we're going to be working on over the next year in conjunction with moving new tumour sites onto this platform. So we've got a project going on at the moment to look at RNA improvement. We're really looking across all areas in the laboratory to find out how we can drive down turnaround times for patients. And I've already mentioned the trial engagement as well. We're working really closely with clinicians. And finally, our ctDNA service is a really important service as well to develop. So that's the end of my slides. So I don't think I've got much time left now for questions. ctDNA moving to next generation sequencing. Yeah, so that's the program that we're going to be working on over the next 2 years, to bring in line all of our services with ctDNA as drugs are developed and as that technology becomes has more clinical utility. Thank you.